Hello, I hope you are doing fine. Let's try to make progress in our program of soil mechanics. Okay, so we are still on chapter 4, which is about plasticity and structure of soil. So in the previous videos, I think we have talked about uh, introduction and liquid limit. This video is about the plastic limit of soil. So the plastic limit, what is plastic limit? I think previously we have talked about this figure, this chart that is showing the definition of each limit, the liquid limit, which is the border between plastic state and liquid state of soil. The plastic limit is the border between the semi-solid state and plastic state of soil. So this plastic limit is what we are going to talk about today in this video. Okay, so the plastic limit is defined as the most content in percentage where the soil crumbles when we roll it in 3.2 millimeter diameter thread. So this is definition. So one important thing is to keep in mind that plastic limit is just the water content. This is the important thing. And water content which allows soil to crumbles when we roll it, like rolling. I will show you soon enough how to do the test in 3.2 millimeter diameter thread. So that limit marks the border limit, the lower boundary of the plastic soil state. As I explained before, if you see the plastic state of the soil, this one is the lower border. The upper border being liquid limit. Okay, so the lower border of plastic stage of soil. So to do the test, the plastic limit test, we need to manually, just using hand or sometime using some specific equipment, manually, we just roll the soil mass on a ground glass plate. The American standard test designation is 4318. Provide the test procedure. This is something like this. You see, you can do something like this, like soil mass about this size. Okay, and then you rule it. You rule the soil mass until you obtain something like this. Okay, if the water content is high, it will not become something like this. Okay, it will not break in threads. But if the water is less, then you can obtain something like this. Some people also use, instead of using hand, you can use just something like this, this specific tool, and you get this kind of threads. Okay, yeah. If you have too much water in your soil, of course you will not obtain this uh, and please remember that it should be 3.2 millimeter. So means that if your soil is too wet, too much water in the soil, you will obtain, you may be able to obtain more smaller than this. But if there is less water, means you will obtain this even before this size. I mean the size diameter higher than 3.2 millimeter. This is the American standard, but I think all standards are about same for what for this test, the plastic limit test. All standards are almost saying same thing about this standard, this test. Okay, so another way to do it is using this Falcon the Falcon method, which is mainly British standard. Okay, which is, we remember in the liquid limit test also, we talked about something like this. It's the same one with some little differences. Okay, so this one is using a cone of the weight of 2.35 newtons. If you remember, the previous one was less than that. And we do, of course, multiple tests at different water content. Can obtain something like this. As you can see here, we have two curves, two lines, this line and this line. This line in that line is for liquid limit we have talked about before in the previous video, I think. This new one, the continuous line, is for the this continuous line is for the liquid limit, and this dashed line is for the plastic limit. As you can see, the plastic limit one, the weight of cone is greater than that of the liquid limit. Here is 2.35 Newton, and for the liquid limit one, the weight is 0.78 Newton, which is smaller. But the procedure is same, and the number of the diameter, the penetration distance is 20 millimeter for both plastic limit and liquid limit. The only difference is the weight of the cone. Yeah. So 20 millimeter. If you are using this cone, 2.35, you will get your plastic limit. You can read it here, the corresponding water content. Another parameter that can be defined now, because now we know what is liquid limit, we know what is plastic limit. We can introduce then this parameter, the new parameter, which is plasticity index. Plasticity index, PI, is the difference between liquid limit and plastic limit. So remember that this liquid limit, plastic limit, both are water content. So by making this difference, we can get this. Actually, IP is in French, so it should be PI. Okay, yeah. So PI, plastic index. Okay, the plastic index is really very important for the classification of soil. Let me just arrange this. Plastic index is used for classification of soil. We will talk about this classification later. Okay, PI. Okay, correct it. Liquid limit minus the actually we should correct also this one. Plastic limit. It was in French, sorry. So the liquid limit minus plastic limit will give us the plasticity index. Okay. Let's continue. So we have this table that gives us liquid limit and plastic limit, and also activity. Activity, don't worry, we will talk about activity later, which is also a very important parameter, geotechnical parameter, activity. So anyway, this table will give us these three parameter for some clay mineral, okay? Liquid limit, plastic limit, and activity, okay? And we will talk about activity in section 6. For your information, this section is section 3, okay? In section 6, which we'll talk about activity. So this table is showing us three parameter for some uh, clay minerals. I think we have talked about all these clay minerals in chapter 1, I think. Yeah. Okay. Just for your information, you can read this later. And this table from this reference is giving us the plasticity index of some uh, like in a qualitative way. If the pi is 0, it means non-plastic. Between 1 to 5, slightly plastic. Until here, if the pi is higher than 40, it's very high plasticity. Okay, so you can read also this for your reference. Okay, I think the plasticity index, as I told you, it's a very important parameter in the classification of fine grained soil. Not all soil, actually. For example, it doesn't have any importance in classification of sand or gravel. However, for the fines, we have defined the size of the fine soil. So for the classification of fine soils, classification, we will talk about this also in the following chapter, I think. So it is very fundamental to use the Casagrande plasticity chart. We talk about this chart in section 7. And this chart is used for basic, the unified soil classification system. We will see this classification system in chapter 5. Here, this chapter is chapter 4, if you remember. Okay, so some researchers, some references work on the relationship between plasticity index and the flow index. Do you remember flow index? In the previous video, we have talked about the flow index. The flow index is just the slope of the curve, the flow line. When we talk about the liquid limit in the previous video, we have seen that after plotting several points, these points follow almost a linear relationship, and the corresponding line is called the flow line or flow slope, flow curve. And the slope of that curve is the index, the flow index. So plasticity index and flow index, these two can be linked with a relationship. And this reference proposed these two relationship for the two method. This relationship is for the method using the Casagrande method for determining the liquid limit. This one is when we use the cone, the four cone method for determining liquid limit and plastic limit. Okay, so from these two relationship, they propose these two equations. Question 6 is for this one. Means plasticity index is equal to 4.12 times the flow index. For this kind, when you use the fault contest method to carry your plasticity, your plastic limit and liquid limit test, you can use this relationship between the plasticity index and the flow index. Okay. So I will just keep these two equations here. After these equations, the reference recently, this reference, another reference, by using 6 inorganic soils and the respective mixture with fine silica sand, they show that they came up with these two equations. CF means clay fraction, smaller than 2 millimeter, means a soil particle smaller than 2 millimeter in percentage. So the plastic limit can be obtained from liquid limit and the clay fraction content, the percentage of the soil particle smaller than 2 millimeter. Okay, so this is the plastic limit and this is the plasticity index. Both can be obtained from liquid limit and the amount of soil particle smaller than 2 millimeter, means clay fraction. So from this experience, we can say that the two equations 6 and 4 and 7 are good when the CF is approximately equal or greater to 30%. Means this, we can trust these two equations only when we have CF equal or greater than 30%. That is the meaning. Okay. But anyway, just for your information, I think that is all for this video. So we will continue with the next section in another video. Okay. Thank you very much.